then, yes, sir? Oh, I was
It would help
feeling
if we
pretty
could
good.
see.
Sorry.
The integral of that, and then I took these two out. But I thought, that can't be right, that can't be doing that. So I moved the two integral 7 squared.
Don't blow the table of integrals off as being too easy. Take it for what it is, and that is, it's a nice little gift, and that is, half the class made 100% on the test last semester, and the average grade was 90, and most of the rest of the class made high B's and A's, and there was just one bad grade. Okay, so make sure, what I'm telling you is study hard enough to make sure that you're in that group. Take it for what it is. This one, the last one, that's 125 points. This one is 50 points. Why? Because it's just 5 problems. This one is 125 points. It's going to have about 12 intervals on it. And the directions will say, evaluate the following intervals. That means you can do it any way you want to, except for the crystal ball method. And that is where the answer miraculously appears to you and you write it on the paper. That method ain't going to work too good. But anything else, what I'm telling you, all of chapter 5, chapter 8, all of chapter 8, except the table of integrals, I am not knowingly and deliberately going to put a integration by parts problem on there. Why? Because you were just tested on it, right? But if you see one on there that can most easily be worked by integration by parts, you can use it. Follow what I'm saying? Okay?
Do you have another little packet of questions?
Do what?
So you have another packet of the table of intervals?
Here, I got an extra.
Wasn't here when you-
I can print you one. You got 2?
Yeah.
Okay. All right. Questions, anybody? I'm going to try to get the registrar, get the dean to ask the registrar to give me another day so I can give you till Monday night when the test center closes. I mean Wednesday night when the test center closes instead of Wednesday at noon. The problem is if the test center, if I let you have until the test center closes, I don't get them to the next day and grades are due the next day. If they will give me another day, I'll let you have from noon on that Wednesday. Okay? All right. So that what that also should tell you is you got to be keeping up with the homework. You need to, as soon as I finish today, you need to do that homework on 8-5. I'm telling you, 100% on a 50-point test really will help you. So do that. Make sure you get that 100%. Then go back and make sure that you have done the section 8-2 homework. That should be your goal by Monday morning. Because tests, you've noticed tests are going to start coming around sort of frequently. Huh? So just keep up. Don't let it snowball on you. That last test, which is basically my final in this course, there are those that say that triple integrals aside, that's still the hardest test they've ever taken. It's just, it'll be problems that you and I can't integrate by standard means, and that we have to use one of my tricks, and that's chapter 8. Okay?
I got a quick question on 5.
Yes.
Like, what if we memorize a bunch of these, and like we say, well, I know that this equals that. Would you go with that, or is that the out of the air thing?
You know, William, I hate to be that picky. If anything on page 1, that stuff on the top of page 1, you owe me no explanation on that. But everything else, I want to see a number.
So you just want us to work it?
Yeah, you know me. All right. This is example 3 on page 481. Yuck. Probably, and we're supposed to use the table of integrals. I probably would try to do it without the table of integrals. I don't like the table of integrals. Isn't that screaming integration by parts at you? Wouldn't you like to try to get rid of the x? But then the problem with getting rid of the x is you're going to introduce a radical with a squared minus x squared in it, aren't you, when you integrate inverse sine? So that's not good. So then you go the other way and you try to take the derivative of inverse sine. Maybe. But then powers of x goes up. I'd try integration by parts first. But we're going to use the table. Somebody give me a number.
I'm seeing number 106 maybe.
What, Jake?
106 maybe? That's what I'm seeing. That's maybe though.
It's a maybe, okay.
I don't know. I really don't see that.
Looks good to me too.
It could be that, or it could be 103 just doesn't have x out.
That's right, and that matters. That matters.
So x doesn't have to have a power to it.
It does have a
Well,
power.
I mean, it's got
Don't you
one.
see that one right there?
Yeah.
So we're going to use number 106, and in 106, n is equal to 1, a is equal to 1, and we get x to the n plus 1 over n plus 1 sine inverse ax minus a over n plus 1 times the integral of x to the n plus 1 over the square root of. Do you see what I mean about these babies? As always, you can tell immediately why they tack on that n not equal to minus 1, huh? Mathematicians are scared to death of dividing by 0. Me, I believe in redemption, and that is, if I divide by 0, if I try to divide by 0, it'll blow up on me anyhow, right? So, I let the problem tell me, but high-class mathematician, mine may not be in one of them, like to worry about stuff like that. Now, I is equal to then, with n equal to 1, that's x squared over 2. Inverse sine x minus 1/2 times the,
What happened?
that interval, Jake.
Oh, like
What about that interval? What does that tell us if our formula has an integral in it? What does that tell us?
Is it integration by parts?
No? Yeah, you know, Jake, that's right. Jake's answer was integration by parts. What Jake's saying is that tells us that they used integration by parts to get this, right?
Yes.
But what else does that tell us?
You gotta integrate it after.
Well, yeah, we got to go again. What we're going to do is we're going to make an integral right here, and then we're going to go back to the table and find us another one. So this is x squared over the square root of 1 minus x squared dx, and I'll let them do that. Now we go to the table again. Anybody ready to call it?
No. Maybe 39.
39.
49.
60.
Oh, yeah, 49 is better.
You know, normally I do what Daniel does. Normally I figure that I can treat a plus sign as a negative sign because I could just let what's behind it be negative. But the problem is you can't make a square, x squared, you can't make it negative even if you try. You follow what I'm saying?
Yeah.
That's why they had to give you another number. Looks like 49 to me. Y'all think so? So this is number 49 with, let's see, let me look at 49, with a equal 1, and that's the only thing in there. If the only thing in there is a, then I'm not going to bother to copy it with the a's in there. Does that make sense to you? So I'm just going to go directly and say then I is equal to x squared over 2. And if you think that these things are a pain to do, it really causes a pain in a part of the body that you normally sit on to grade all these things. Because it's just so tedious, isn't it? Now that's what a problem on the test ought to look like. And that's what I ought to see on there. It is important to me that you put the number. To be honest with you, that's because I don't want to have to go to the table of integrals and look up and see if you use the right one. You help me that much as far as grading. Then all I have to do is check and see if you substituted in right. Virus?
Is there gonna be any cases where we could use like more than one to get the same answer?
Yes. Yes, there could be.
'Cause
And it doesn't matter to me.
Okay.
It doesn't matter to me. If you use one that I don't, like suppose number 69 would have worked. It won't. But suppose, I don't even know what 69 is. But suppose number 69 would have worked right there. I won't immediately mark it wrong if you don't have 49. I will go to the table and look at 69 and see if you could have used it. Virus?
So look at 60 and see if I could have used that one.
On the whole thing or on the last one?
On this problem.
On right here or up
Yeah,
there?
The last.
Right here,
X squared is positive. That's
where I'm pointing?
Yeah.
Page number 69. Yes or no, class?
I don't think so. X squared
Number
is
60.
positive.
Number 60.
Number 60.
60.
But I mean, you could.
Yeah, you can't do it. Here's the reason
Because of the
why.
sign change?
It is true, Byers, if that had been just, see, the problem is, in our problem, x squared is negative.
Yeah.
If that had been just an x, you could have done it,
Oh,
couldn't you?
I see what I was thinking.
But that x squared is like Daniel and I were talking about a minute ago. You can't switch that sign, even
Yeah,
if you try.
I was thinking about squaring the sign, but the sign isn't with
Yeah.
the X.
I'll tell you where you can do that sometimes, is at the bottom of page 1 and the top of page 2. Sometimes those A plus B forms, that could be a minus B problem, couldn't it? You follow what I'm saying?
Yeah.
Yeah, because the number is squared makes positive.
Because you just let B be a negative number, right? But when you square it, it ceases to be a negative number. Okay?
But you can't touch the X unless there's an A next to it for that.
Say what now?
Like you can't change the sign of the X unless there's an A in front of it.
Yeah, that's enough. That I would say yes to that. I don't have any more. Let me tell you that I put a problem on this test where you will have to use numbers 129 through 154. What am I telling you?
You've got, my spot close
Yeah, do you remember, I had a teacher in graduate school that had this marvelous saying, and it's hand wave. Hand wave means you're in a hurry, and you just wave at it as you go by. And that's sort of what I did to hyperbolics, wasn't it? And I told you that we were going to, at least for now, treat them like table of integrals problems. And that's why I put one on there. Okay? So isn't it just a matter of treating it like any other problem in the table of integrals?
Just make sure you pick the right one.
Yeah. And it is an easy one, but it's just to make sure you know that for right now, our solution on hyperbolics has to do with the table of integrals. Okay? That's 8.5. You are ready now to take the test.
Put on the test. Yeah. Okay, good. But I don't know if it's within X squared though. I wrestled with that one for a while. That's tough.
I would say if you need to first do those homework problems. That will, the more problems you do, the more comfortable you'll get with that table. Then I think you need to be able to do numbers 1 through 31 on page 485.
For 8.5?
Yeah, that's 8.5. That will help you do some of those. That will help you make that A on that test. And you, as I say, take advantage, take this for what it is. If you have 100 on homework, or even if you have a 90 on homework, you and a 100 on this 50-point test, you're building yourself a little bit of a cushion. And I tell you again, that final cushion might be worthwhile. I remind you that all the homework is still open. From the first section, it's still open.
That's eyes burnt.
Oh, pardon me, Jake. Did everything come out all right?
I think so.
Okay, good. We're all pleased. From the first section, it's open. If you have any assignment where you have less than an 80%, go back and do that. And then if you do the remaining homework and make 100%, and go back and get that old stuff up to 80%, that ought to put you around the 90%, huh? Okay? All right. We've done 8.1, 8.2, and 8.5. That leads us to 8.3. For some reason, students want to make 8.3 hard, but it's sort of fun.
This is test 5. This is all test 5 here?
No, the only thing on test 5 is section 8.5.
Okay, so test 4, which is the fun.
All of chapter 8 except 8.5 will be on test 4. Except, let me say it again, I'm not knowingly and on purpose putting an integration by parts problem on the test, because you've been tested on that. But if you see one and you want to use integration by parts, do it. And that ought to be looking pretty easy to you now. So use it when you can. It's always my first choice is integration by parts. Then the next one is section 8.4, which is partial fractions. You're going to like partial fractions. Okay? Here we go. I did not say you were going to like 8.3.
I was going to say, because I think your definition of fun and mine is two different things.
Say what, Jay?
I said, I think your definition of fun and mine is two different things when it comes to this.
Well, Jay, for our listening audience, I won't have them turn the camera off. At my point in life, good-looking girls just don't enter into the equation. Good-looking young girls just don't enter into the equation. So you have to find it another way. This is trig substitutions. This is example 1 on page 468. I choose not to give you any formulas. I'm going to tell you how to do it instead. means ugly with a capital U. What? What did it?
We've already covered that form.
How you gonna work it?
How to work.
We covered the X2 over that, but we didn't get
The inverse sign of X over,
Oh, you're saying using your card.
yeah, I mean, cause that's 2 squared plus X squared.
Yeah, that's fine.
Okay.
That's fine. That's fine. How are you gonna get that? That's what I'd like to know. You're not gonna be able to use your table. Daniel's got it written on his card. I don't even mind if you have it written on your card. But when I say on the test, evaluate the integrals, as you know, that doesn't mean write the answer. That means I want to see some writing. So what I'm asking now is, let's suppose that you don't have it on your card. Daniel's saying, I know the right answer. He does. But I want you to show me what to do with it. And to try, I left off a dx, and to try to integrate that baby by conventional means, or even integration by parts, is not going to be fun. Would you agree? So here's what I'd like to do. I'd like to change this. I would like to let x be a trig function. So I can change it to something, to a trig function, and get out of this mess. So what I want to know is, I want you to think about the trig identities, and I want you to tell me about one that has 1 plus something equals something. And I want, that's good enough. That's what I said here. For example, sine squared plus cosine squared equals 1, right? The problem there is, if you tried to use one of those, wouldn't you have sine squared equal to 1 minus cosine squared? So you can't use those. I want something that has a 1 plus and a trig function in it. What is it?
Plus cosine 2x to the cosine squared.
I just want to know, I'm talking trig functions, not calculus. I think that secant squared theta is equal to 1 plus tangent squared theta. Don't you? Do you remember I showed you, if you don't have that memorized, I showed you how to get it, right? Okay? So what I would like is, I'm going to have tangent squared theta right there. Okay? But then I've got this 4. So what I want to do is I want to be able to factor that 4 out. Okay? So what I'm going to say is, let x be equal to 2 tangent theta. Then x squared is equal to 4 tangent squared theta. And dx is equal to what? Exactly, thank you. 2 secant squared theta, d theta. Okay? So, I'll write it out as a rule for you, just for you, but I don't try to remember these rules. I just remember trig functions. Rule 1. If square root of a squared plus x squared, let x equal a tangent theta. That's rule 1. And the reason, let me show you why I picked that. Watch what happens. Now in this case, we do just like we did before. I know what this equal sign means. That equal sign means that it's equal to I, right? So, I'll just put it for you. I is equal to the integral of 1 over the square root of 4 plus 4 tangent squared theta times 2 secant squared theta d theta. Didn't I just substitute in? Everybody agree? Any questions? Don't hold out on me. This stuff is going to be new to you. It's not going to be hard, but it's going to be new to you. So don't hold out on me. Tell me if you got a problem. So wouldn't you say all I did was use rule 1 and then let the chips fall where they fall? Is that right? But I take note of the fact that this is equal to 4 times 1 plus tangent squared theta. You would agree with that, wouldn't you? And if I do it, you can do it one time. Draw a line through it and you can change it, save yourself writing a step one time. I don't want to have a bunch of lines drawn down the page, but if you want to do it one time, I don't mind. Particularly for something that obvious.
Still under the radical.
It is. It's sort of understood that it's under the radical, but I just rewrote what was under the radical. And that's why I said I just want you to do it one time, because you'll remember to put it under the radical if you just do it one time. Now, that leaves me 1 over the square root of 4 secant squared theta times 2 secant, times 2 secant squared theta d theta. Do you agree?
I mean, it's 1 plus tangent squared.
Say what, Jay?
No, I thought at first you multiply that secant squared theta by, but I forgot 1 plus tangent squared theta secant.
That's right. All I did was use that substitution, that trig identity. Okay? Now, you tell me, what is, here's the 2, what is the square root of 4? So doesn't that put another 2 out front? What's the square root of secant squared? Yeah, isn't that who's buried in Grant's tomb? So this is 1 over secant times secant squared theta d theta.
No, you're moving it.
Anybody in here have any for trig? You would not believe how ugly I act in trig. when people leave the angle off. And that is, I'll give you my speech, that is what you do when you make the Lord mad at you. That is. That's what you do when you make the Lord mad at you. This has to do with the sides of a triangle. What I'm telling you is that without an angle, a trig function means nothing. And that will earn you a -1. Okay?
Okay, you had 2 times 2 out there?
Yes.
The square root of 2, I mean the square root of 4, wouldn't you divide by 2?
Of course. Thank you. Thank you, both of you. Thank you. Okay? I was too busy worrying about sinning. Okay? Now that ugly C word that you guys use.
What, cancel out?
That was the word. That one's just got to go on your card. The integral of secant x dx just has to go on your card. You're going to use it too much in this section. And we're through, right? You got to go back to x, huh? Everybody agree?
That's just plug it.
All right, Jake, plug it in.
Wouldn't you just put X where the thing is?
Yeah, isn't that gonna be pretty? That means, don't write this. That means that I is equal to the log of secant of 2 tangent theta plus tangent of 2 tangent theta plus c.
That's fine. No.
So what do we do?
Nothing.
Oh, Jake.
Just lay down and ride.
Watch this. Watch this.
Just leave it as
X is equal to 2 tangent theta. Exactly. So that means that x over 2 is equal to tangent theta. Would you agree? But this is equal to the opposite over the adjacent. You remember that from trig? Everybody? So, I need to know what that hypotenuse is. What is it?
Pythagorean theorem of x.
He's right. Pythagorean theorem. Huh? So, this side, H h squared is equal to x squared plus 2 squared, or h is equal to the square root of x squared plus 4. Agree? Agree? So now I know this side. Now, that means then that the secant of theta, secant theta goes with which other one? Secant theta goes with, you didn't have me for trig. I teach my trig class goes with. Goes with means sine and secant go with cosine and secant go with each other. And that means goes with means this, doesn't it? So wouldn't you agree if I knew what the sine was, I could get the secant real easy? The cosine.
Yeah.
So the cosine I know to be the adjacent over the hypotenuse, that's 2 over this, right? So what does that make the secant?
That over.
It's the square root over 2, huh? So the secant theta is equal to the square root of x squared plus 4 over 2. And we may as well go ahead. We know what the tangent is, right? Agreed? So, doesn't that mean, now I'm going to use this and put it right there. And I'm going to use this and put it right there. And when I do that, won't I go back to x?
Yep.
Do you agree? And that's what I do. So what I'm going to say is that I is equal to the natural log of square root of x squared plus 4 over 2 plus x over 2 plus c. And that's what you call a trig substitution. Questions?
I'm sure it gets worse with time.
Is the question going to be, what am I doing? I'm scratching my back. Okay, what? Yes, sir.
So is there a way to do substitutions with hyperbolic trig functions? Because I guess that's what they do on the tables.
What do you, show me what you mean.
For this one, that's the same form. And they get
Yeah,
hyperbolic.
it's very much like hyperbolic, yeah. Yes. In fact, well, that one, which one? Show me, I'm reading upside down. That one is that table in the book on hyperbolics. That's all that one is. Okay? But yes, you can do the same thing with a hyperbolic. You would just have to use the hyperbolic rules with it. Yes. And I've had to do that in graduate school. You won't have to do that in this course.
Where did that lim secant plus tan come from?
That's one I told you to put on your card.
Is it
That ought to be,
Is it not on here? I don't see it.
it ought to be in that first group.
Did you like manipulate it?
No. Are you calling me a manipulator?
Is that what we do here?
down,
I'm
and
saying.
yes.
Basically what we do here.
95.
95.
The 95?
Let's see what,
Yeah.
95 it is. Put that on your card. That's just gonna come up so often, it needs to be on your card, particularly in this section. Okay, let's do another one. Now, any questions about how to do them? Okay? Another one. Didn't I tell you these were fun? See what I mean, Jay?
I got a lot of fun.
See, I knew you could.
See what I did about your definition of fun not being mad?
Yeah. If you think that one's fun, you're gonna really love this one.
I don't think the definition of like sit for the dog, if that's fun, and it just gave away.
Yeah.
Eventually it will be fun.
Rule 1 says if it's a squared plus x squared, let x be a tangent theta. Can you look at that and tell me what I'm going to use? Daniel's about to tell me.
Yeah. Same.
If I let x be 3 cosine theta, when I square it, don't I have 9 minus 9 cosine squared theta? Factor the 9 out, and don't I have 1 minus cosine squared theta? Mm-hmm. So, rule number 2. If we have the square root of a squared minus x squared, use x equal a cosine theta. Someone asked me the obvious question. Think about that for a minute. What should you be asking me?
Where's the A gonna come from?
No, the A, you know what the A
Well,
is.
I mean, just-
Yeah, but I need it, no. What I usually get asked is, could I have used a sine theta instead?
No,
Why?
because of how it's set up in the square root.
Yeah, but,
Because one minus the cosine of square root of theta is the sine square root of theta, but it doesn't work the other way around. One minus the sine square root of theta is not.
yes it is.
It's the sine, wait.
Yes it is.
Oh, yeah, it is, because they're just added together. So
Yeah.
you subtract either one.
Yeah, you move either one to the other side, don't you? Right?
Yeah.
I wrote that because that's what the book says. I think that's what the book says. No, they use sine. I'll be. Okay. They use sine. Does that tell you can swap them back and forth? I do them whichever way suits my fancy at the time. Your book says use a cosine theta. I'm telling you it doesn't matter. But I'll do it the way your book does. So, I'm going to say that x is equal to 3 cosine theta. Then x squared is equal to 9 cosine squared theta. And dx is equal to, minus 3 sine theta, which is why why we should do it my way. But the minus doesn't hurt us. It doesn't hurt us. Everybody agree? All I did is apply Rule 2 and then let the chips fall where they fall. So now, I is equal to the integral of 9, no it's not, is equal to 9 times cosine squared theta over the square root of 9 minus 9 cosine squared theta times a minus 3. I didn't leave myself enough room to do it. Doesn't that get it? Student told Dr. Freelow one time when he was doing circuits that they were used to seeing lines with arrows going everywhere. They'd had me for calculus. Okay? Minus 27 times, and I'm going to take advantage of, and I'm going to write that as 9 times 1 minus cosine squared theta. You and I will agree we can do that once. Yes, sir?
How do you get a -3?
What's the derivative of cosine?
Negative sign.
That's how I got the -3.
Yeah, I mean.
How did I get that -3?
Oh, okay.
I took the derivative of cosine and got minus the sine. So I got minus 27 times the integral of cosine squared theta over the square root of 9 sine theta times sine theta d theta. What did I do? Everybody okay? Fine? I left my square off. Okay? Now, this then is equal to minus 27 times the integral of cosine squared theta over sine theta times sine theta d theta. And this much is 9. These two divide out, and now I have the integral of minus 9 times the integral of cosine squared theta d theta. And now all I have to do is integrate that. And you know how to integrate that, don't you? It's time for the handy-dandy 3x5 card, isn't it? Would you agree? Does everybody know what I'm talking about? That's one of those two that early on I told you to put on your car, cause it'd get you out of a jam. Here's a jam. So now I have,
I don't know what I got on my card then.
well, Daniel, maybe I did it wrong. Did that ever occur to you?
No, I usually think I'm the one who messed up.
Here's what I remember. They both have 1 and cosine 2 theta in it. If it's cosine, it's a plus. If it's sine, it's a negative. About all you need to remember is to look at the card. So now don't I have
Completely.
I think there's two of them.
what goes in the blank?
Okay.
What do you need to have in that blank to have cosine u du? Very good, Jay. Don't you need a 2 right there? And if you put a 2 there, don't you need a 1/2 right there? All I did, come on now, all I did is in my head, I said, let u be equal to 2 theta. Du is 2d theta. So I wanted to make it cosine u du. So I just wrote 2d theta. But I can't just jump up and put a 2 there. I have to multiply it by 1/2 out front to keep from changing the problem.
But that two's not there.
What?
The two's not actually there though.
It is there, but it's about to go away.
The 1/2 won't go away.
The 1/2 won't go away. I agree with you on both terms. Okay?
Who's basically down there?
So I have now, see if I don't have minus 9/2 theta minus 9/4 times sine 2 theta plus c. Everybody agree? Don't let me cause you problems. Do not allow me to cause you problems by doing this. Do not allow me to cause you problems by doing this. If you don't like doing this, do it the way I taught you the first week of the semester. And that is, let u be equal to the angle and just write it out. So don't let this shortcut cause you trouble. If you're not 100% satisfied with it, just write out u equal. Okay? Yes, sir? Yes, sirs. That's a bad sign when 2 of you. What did I do wrong?
You have to divide by 2 and get the integral cosine 2 theta.
Yeah. Are you asking me about this one, why I put that there?
No.
You're asking about that? What do you not like then?
I'm wondering about the sine.
So it does.
Oh, the integral of cosine is what?
Isn't it negative sine?
Minus
the sine.
plus
Oh, I'm going back.
No, you're worried about putting another 1/2 in there, right? You took care of that when you put this 2 right there. And see, I put that 1/2 out there then for the very reason you're thinking about. And that's why this is 9/4 instead of 9/2. Okay, Jay?
We're good. I
Okay.
did it backwards. I did the derivative of cosine
Yep.
as negative sine.
Yep.
You take
It's easy to do, I understand. When you said it, I understand. And you know why I understand? Because I used to do that. Yes, I understand. And I may yet do it again. But Daniel,
So, I don't really remember why this is on my card, but I have the integral of cosine squared of x written on my card, which is what we got. So if I made that jump without those two steps in between, what would you say?
let me see.
Which would give us 9x over 2, in this case theta, minus 9 over 4.
That's pushing me.
I don't even know why it's on my card.
Yeah, that's pushing me. I probably would give you the benefit of the doubt. I probably would give you the benefit of the doubt. But, you know, Daniel, I try to cut down as much as I can on stuff you have to remember.
Me too, that's why it's on my
And the
card.
card, and I know, I knew you were gonna say that, and the card is sort of first cousin to remembering, is what I'm saying. I'd rather you just remember what cosine 2 theta is.
Yeah.
I mean, or cosine squared theta is. But if you were to do that, I think I'd give you the benefit of the doubt. And if I count off for it, remind me of this discussion.
Okay.
I'll always treat you fairly. Now what's the rub?
You got the theta, so you got.
I gotta get back to x, huh? So the first thing, about the only thing I know right now is that x is equal to 3 cosine theta. So that means that cosine theta is equal to x over 3. Is that right? Everybody agree? That also means that theta is equal to inverse sine, I think I'm going to write it arc sine. Arc cosine arc cosine means. Dr. Thomas, you want to tell them what arc cosine means?
The angle whose cosine is.
That's right. What Dr. Thomas is saying, arc cosine says theta is equal to an angle whose cosine is x over 3. Is that not exactly what we wrote above it? Do you agree?
I agree.
So arc sine inverse,
I said it.
or